This video will continue looking at triangle trigonometry, and we will continue looking at oblique triangles, section 10.4, and how to solve those triangles. So in this specific video, we want to look at a case 2 study, but specifically when it is an ambiguous case. And so again, an ambiguous case is when you have a case 2 trigonometric decision on what type of problem it's going to be and what type of answers you might have. And so you can determine that it's not a right triangle, that you are given an angle and a side, and in this case you're given an angle and two sides, with one of the sides being opposite of the angle. And so that's going to lead you down the path to a case 2. And then if you're given the fact that that angle is acute, then you have an understanding that you might have a your answer either might have no solution, it might have one solution, or it might have two solutions. And I want to just start out by showing you what two solutions mean before we go into solving it, so you kind of have an idea in your head of what that looks like. So what it is if you have a triangle and you're given a triangle, there's a possibility that you may be given a triangle that has an acute angle in it, or all three acute angles. But then again, it might also describe, if you're a triangle with a obtuse angle as well. And so if you're given this angle of 33 degrees, it might describe either a acute triangle or an obtuse triangle. And it can be describing both, and that's how you can get two possible answers. Hopefully this will make more sense once we jump into the problem and look into it. One of the things I want to make sure to point out is that we will be testing for a second possibility in these ambiguous cases. And you might say, well, Professor Woodgate, why didn't we check for a second possibility with the other two case 2 problems that we're looking at that were also acute angles? If you'll remember, one of those was a 30, 60, 90 triangle, so automatically you know that you're not going to have an obtuse angle in that. And the other one, if you remember when we solved it, it was one of those that didn't have a solution. And so now we're going to look specifically at cases that you come up with a solution, and you're going to need a test for a second solution. So let's go ahead and look at this. We're going to follow our flow chart like we have. And so if you're given this problem on a test, is it a right triangle? And so we determine that no, it is not a right triangle, at least as far as we know it's not. And we've seen that if it is, we can figure that out as we solve it. But we're going to treat it like it's an obtuse triangle. Excuse me, like it's an oblique triangle. And so it's not a right triangle. And we are given two lines and a angle. And so we have a side A and its opposite angle. So okay, we're going to go ahead then. We know that this is a case 2 problem then. Is it an obtuse angle? No, it's not an obtuse angle, so we know that it's case 2 and it's in and it is an acute angle, so it can possibly have 1, 2, or no possible answers. Okay, so then we know that we can work with the law of sines to be able to figure out the answer to this problem. And I'm just going to bring this down here. So it's a little bit easier for us to work with on one page. All right, so we know that we are going to be working with this problem. Let's go ahead and use our law of sines to figure it out. And we're going to be looking for a sign, so we're going to leave the signs on top. So we're going to put sine A, and let me just go ahead and write in sine A. Sine A is 30 degrees again, and this time it is over 4.62 feet, and it equals sine B, and it is over 3.75 feet. Okay, so let's go ahead then, and we are going to eliminate those so we can solve for sine B, and get the calculator. And so we have 3.75 times sine of 30 and that divided by 4.62, and that gives us, all right, well, it gives us a decimal, which is good. That's we need that to be a decimal so that we know that this is and remember, if it was over 1, then we would know that that was no answer then. And so this is sine B. So now to be able to figure out what the angle is, we'll go inverse sine, and tells us that angle B is 23.9 degrees. Okay. All right. So we can actually also, maybe start drawing this out a little bit. Let's figure out what the other angle is, though, first, because we know that the inside angles of a triangle all add up to 180 degrees. So let's go 180 minus 30 degrees and minus 23.9 degrees. Sorry, when I put my pin on here sometimes differently, and sometimes it doesn't work. Let's redo that one. So 180 degrees, not much better, minus 30 degrees minus 23.9 degrees. And so getting our calculator. It's minus 30 degrees minus 9 degrees. And so that gives us that our angle C is going to be 126.1 degrees. So let's see. Just because I'm a visual person and I like to be able to see things, so let's make this C. That's 126.1. We will make this one A, and it is 30 degrees. Make this B, and we said that that was 23.9 degrees. And these are all degrees. Okay, and we also know then that A is 4.62 feet. We know that B, so opposite of angle B is 3.75 feet. And C, well, we don't know yet. So we can figure that out. So let's go ahead, and now that we know sine C, we can get that figured out. And so, and we'll go ahead and start this again. Whoa. Sorry, folks, don't know what's going on with this one. Okay. So, sine, we'll just go back to sine A since we've been using that one. Sine A is sine of 30 over, and actually, you know what? We're going to be looking for the side. So let's just flip this, and we're going to put our side on top is the numerator, so side A is 4.62 feet over sine A, which is 30 degrees, and that is going to equal, we don't know what C is, and we're going to look for sine C, which is 126.1. Okay, let's go ahead and get C by itself, 126.1, 26.1, and these will cancel out. Make sure we're clear. 1 times, oh, and excuse me, that was sine 126.1. Sine, that would have made a big difference. Let's go ahead and clear these out again and try that. Okay, 126.1 sine times 4.62 divided by sine of 30, and that gives us that C equals 7.46 feet. 7.47 feet if we round it. Okay, so let's go back to our triangle. C is 7.47 feet for C. And so that looks correct. All right. Now, here's the thing. So we made it all the way through. It's not a 30, 60, 90. It's not that it's incorrect. Now that we made it all the way through, we need to stop and think, okay, go back to remembering this is case 2. This is an acute triangle. Does this have a second answer? We've got one answer. Does it have a second answer? So the way that we find that out is we go ahead and look at the angles that we have, and we look to see if there could be an alternate angle. So remember when we found sine, the very first one that we found sine B up here. That the sine, so for sine B, that could be, so sine B 0.409 could be the obtuse angle that is the opposite of 23.9 degrees. So we need to make sure and see if it is or not. And the way that we do that is, let me go ahead and see if I can get this. I'm going to bring it down here. And if you're wondering where this came from, remember this came from up here, from 23.9 is sine B, so, and this is it right here, this 0.409 is sine B, and so we hit the sign of that. So now let's look and see if it could be. So what we'll do to be able to figure this out is we'll say, okay, out of the 180 degrees that this could possibly be, if this was 23.9 over here, then there could be a whole nother angle that is over here that matches the same sign. And so to find that, we're going to subtract 180 minus 23.9, and we're going to get and we're going to get 156.1. So now what we're going to do is we're going to say, okay, if this triangle, because remember, we don't know what this triangle looks like over here yet. We see that we have one triangle over here that looks like this, but maybe there's another one. And so we're going to say, okay, if we took this 156.1, that it might be we add that to the 30 degrees that we were given from A at the very top up here, then that's going to give us 186 degrees, which means that there is no possible way that you would fit in side C, or angle C on that. So that means that this is the one and only answer for this problem. Okay? So if that didn't make sense completely, you make sure you can go back, you can look at the book, you can look at the PowerPoints, you can also follow along to the next slide where, hint, hint, the next slide will show you that there are two solutions, and you'll see what I mean maybe a little bit more. So let's go to the next one. Okay, if you'd like to pause the video and try to solve this one on your own, the same way we solved the last one, and see how far you can get, and then try to see if there's a second answer, because as we look at the flow chart, we'll recognize that this is a right, excuse me, this is not a right triangle. Okay, we've already determined that, or at least we don't think that it is. And we know that it has a side and or two sides and an opposite angle, and that opposite angle is opposite of one of our sides. And it's an acute angle, which means that there might be two solutions because it's case 2. All right. Go ahead and bring this down, and we'll move this one a little bit faster than what we moved the last one, because this first part is just the same as we did the last one. We're just going to move this through the law of sines and figure it out. And so we are going to get, and hopefully my pen works better, sine A over 4.62 equals sine B over 5.48, and we're going to 48, clear our calculator. We're going to go 5.48 times sine of 30 divided by 4.62. And all right, well, we get a fraction, or we get a decimal, I'm sorry, that's less than 1, which is good for sine B. So that means that when we're looking for angle B, by taking the inverse sine, that 36.3738 is our sine B. And so there we go. So we've got that, and or excuse me, for our angle B. Okay, so now that we've got two of our interior angles, we have a interior angle of 30, and we have an interior angle of 36. And so let's see, let's go ahead then, and we're going to look at this and say, all right, and what is C? Well, 180 minus 30 minus 36.38. And so that's going to be 180 minus 30 minus 36.38 is 113.62. So C equals 113.62 for this particular triangle. And so we can draw this out. And so we know it is I have an obtuse angle here. We were given an acute angle, A, of 30. We have angle B, which is 36.38 degrees, and we have angle C, which is 113.62 degrees. We also know that angle A, or excuse me, that side A is 4.62 feet, and that side B is 5.48 feet. So now we need to figure out side C, and so to be able to do that, we will go sine, actually, again, let's go ahead and flip this so that we can get C on top, because that's what we're going to be looking for. We have sine C, sine 113.62, and that's going to equal, we'll go ahead and look at A again, 4.62 over sine 30, and we want to get C by itself, so we will be multiplying sine 113.62 to the top over here times sine 113.62 over here, and this cancels those out. Let's go ahead and get the calculator, and so 113.62 sine times 4.62 divided by 30 sine equals, so we can see that C is 8.47 feet. 4.7 feet, and so that looks right on that. Now we're going to remember that this is an acute. We were given an acute angle at least. Remember back at the very beginning, we were given that we had two sides and an acute angle, and so that's case 2. And since it's case 2, it might have two possibilities. That might be two solutions. So let's go back to our sine B that we were given up here, and the angle that we were given from sine B. And there's some space here. So we're going to go ahead and call this test 2. And so we want to be able to make sure to see if there is a triangle with a different angle in here. And so the way that we're able to do that is we need to go back and look at the angle that we started with. So remember, we were given angle 30 degrees, and we came up with angle B, which was 36.38 degrees. And remember that for every acute angle that we determine a sine value, there is an obtuse angle, and that is 180 degrees minus that angle. And so let's go ahead then, and we'll come down here and go 180 degrees minus 36.38. And we get 143.62. Uh-oh, my pen's gone wackadoodle again. Try to see what I can get here. At least you'd be able to 143.62. Okay, and so once I have that, then that is going to be my new angle B for this second test. And so I'll go ahead, and since I had that in red, I'll go ahead and make this in red also. So that's my B prime, or so this is for my test of my second triangle. So I know A is 30 degrees, and I know B is 143.62. So to find C, so I can take 180 minus the 30 minus 143.62, and this is just a test. Remember, even if there is a second, answer, the second triangle here. So 180. Is there enough room in the triangle to be able to actually fit another angle? So 180 minus 30 minus 143.62. And I get 6.38. So there's actually some room that can be in here. And so C equals 6.38. So I have my angle for C. So now the only other thing that I need to figure out is I need to be able to get what the length of the side C is. So let's kind of look at this second triangle and see what this looks like so far. We have a very flat triangle because this is 143 degrees, 0.62 for angle B1. So for A sub prime, it's still 30 degrees. And for C, it's just 6.38 degrees. And we have a length for A is still, A and B are still our original numbers, 4.62 and 5.48. So 4.62 and 5.48. Excuse me here. Label those incorrectly. There we go. Let's get that back because this is C and this is B. Oh, no, sorry. No, just a second. I had that correct the first time and shouldn't have gone and changed it. Okay, so this is B and this is C. Okay, and because this is the B prime. Okay, and so what we need to do is we need to figure up the length of C. And so to be able to do that, we are going to go 4.62, which was A, and sine A is sine 30. This is from what we started with up top, what we were given. And sine C, we're looking for side C, and we're given sine C is 6.38. We want to get that off there. 6.38, and that's sine. And so go ahead and get the calculator. I'll calculate this out. .38 sine times 4.62 divided by sine of 30, and that gives us 1.0267, which is C is 1. We'll round that to 1.03 feet. And I don't think my my picture is actually very clear for what it should be, but we end up with the correct answer as the side is 1.03 feet. Oh, all right. Just remember that when you're looking for that second test, what you're doing is you're taking your initial angle that you've calculated, So that 36.38 when you found the sine of B, and the angle for B, and you're subtracting that from 180 degrees to get a number to see if this number added with the first number that you've got is less than 180 degrees so that it fits a second triangle. And that concludes this video.